In this problem, the efficiency of Carnot engine operating with a hot reservoir kept at a temperature 1000 Kelvin is 0.4. It extracts 150 joules of heat per cycle from the hot reservoir. The work extracted from this engine is being fully used to run heat pump, which has coefficient of performance 10. The hot reservoir in the heat pump is at temperature 300 Kelvin. Which of the following statements is or correct? So as it is a multiple correct answers type question, so we go with the options. So first, whatever the data given, let us take that one. So Carnot engine. Carnot engine is like this. So this is hot reservoir. It supplies heat. This temperature is T1, and some heat is gone to sink, and this temperature is T2, and this is the work done, right? So the efficiency given, efficiency formula 1 minus T2 by T1. So 0.4 is equal to 1 minus T2 by T1. So T2 by T1 is equal to 1 minus 0.4, that is 0.6. Now T2 is equal to 0.6 into how much is T1 given? 1000 Kelvin. So into 1000, that is 600 Kelvin. So here the T2 value is 600 Kelvin. T2 is equal to 600 Kelvin. Now, so 600 Kelvin is the T2 value, that is the sink value. Now 150 joule, it extracts 150 joule. So from this hot reservoir, this Carnot engine is taking 150 joules of heat. So I will take it as Q1, heat per cycle. So per cycle it is taking 150. So here how much is going? This is Q2, right? This will go like this. So per cycle 150. So we can use the formula of this entropy. Entropy, because the Carnot engine is a reversible cycle. So what is the formula for this one? Q1 by T1 is equal to Q2 by T2. What is Q1? 150, right? So what is T1? T1 is equal to 1000. Q2 we don't know. T2 is 600K. So these two zeros, this 0 goes. That implies Q2 is equal to 15 6 are 90 joules. So here Q2 is 90 joule. So work is equal to, we got 150 minus 90. So 150 minus 90, this is equal to 60 joule. So 60 joule is the work per cycle. So far whatever the results we got, let us check which option is correct. First option, the work extracted from Carnot engine in one cycle is 60 joules. So we got the answer. So option A is correct. Temperature of the cold reservoir of the Carnot engine. Cold reservoir of Carnot engine is 600 Kelvin. That also correct. So now third option C is a heat pump. So heat pump. So let us come to heat pump concept. So this is a heat pump, where it is heat pump. So a heat pump, this is the heat pump. The heat pump 60 joules we are giving from the Carnot engine. 16 joules heat we are giving. This is a hot reservoir. This must be kept at 300 K. This is sink. So some heat is taken, and finally the temperature of the hold we have to calculate. See how much we supplied, 60 J. Then what they have given, coefficient of performance. Coefficient of performance formula, desired temperature, so desired output by input. This is the formula for coefficient of performance. Coefficient of performance 10 is equal to desired output. So desired output we have to calculate. Desired output by input. Input is given as 60 joule. So 60 joule. So desired output, therefore desired output is equal to 10 into 60, 600 joule. So this is a desired output. So I'll give this as a T3. This is Q3, that is 600 joule. This I will take T4. So here 60 and here whatever the heat it is taking from this sink, this is Q4, that is equal to 600 minus 60, 540 joule. Option C, temperature of cold reservoir. So option C, temperature of the cold reservoir of the heat pump. Cold reservoir T4 we have to calculate. So same relation we use, the entropy relation, Q3 by T3 is equal to Q4 by T4. Q3 how much? 600 joule by, same formula we use, 600 by T3 is equal to 300 is equal to Q4 540 by T4 we have to calculate. 300 ones, 300 twos. So here T4 is equal to 540 by 2. So 270 K. So T4 value 270 K. Right? So option C also correct. What is option C says? Temperature of the cold reservoir of the heat pump is 270 K. So this answer also correct. Heat supplied to the hot reservoir of the heat pump in one cycle is 540 joule. No, in one cycle heat supplied to the hot reservoir is 600 joule, but they have given 540 joule. So D is wrong answer. So for question number 8, A, B, C, three options are correct.